Hi everyone. We're picking it up here in 3.1. I'm going to go through 3.1, 3.2, and 3.3 in this video. Again, the idea is I'm going to go through some of them, and then you can, of course, have your choice. You can pause, try the one next to it, or you can just watch the whole video in parts, whatever you want to do. But my original thought was, okay, I'll do some of the problems, they'll kind of pause the video, they'll try the other problems, and then what I do is I attach a key to the entire thing next to the video. So you can watch me work some out here, and then you can look at the work if you want. So anyways, that's the idea, but make it work for you. So we're getting into graphing, making pictures out of equations. Basically, is how you can think of that. So just to explain the idea a bit, imagine we wanted to find answers to this question, right? A number plus a number is 10. So maybe over here I'll keep track of some numbers at work. So a number plus a number equals 10. 4, if x is 4, then y must be 6, right? That would be one example. If x is 3, then y must be 7, right? You can probably think of many of these. So 2, 8. -6, right? What if we have -6? Then I just need 16, I guess. I'll continue over here maybe. So let's do x and y again. What about just 5 and 5? They can be the same number. What about decimals? So 4.5 and 5.5. What about 4.6 and 5.4? Right, how many are there? There are infinitely many. So maybe you can see how you can just keep finding pairs that do this. If we plot some of these pairs, so we had one here, I'm going to treat this like my x, this like my y. So we had one solution that was 1, 2, 3, 4, 5 in x, and then 1, 2, 3, 4, 5 in y, right? That point right there is this point right here. Okay, so you can plot other ones. So what if I plot 4, 6? So 4, 6, I count 1, 2, 3, 4 in the x direction, and then 1, 2, 3, 4, 5, 6 in the y direction. Okay, let's do some more. What about 3, 7? So 3, 7, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. I didn't write it, but what if I did 7, 3? You know, I can just switch all these. So 7, 3 would look like 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. And now you can kind of see or get a sense for what's happening. You know, is it random? No, these points are falling in this straight line. We did do one that was 4.5 and 5.5. So 1, 2, 3, 4. 0.5 would just be halfway in between 4 and 5. And then count up 5.5. 1, 2, 3, 4, 5. And then go up halfway. So that lands you maybe expectedly on that line, right? And if you do this infinitely many times, going to use this other book as a straight edge. But if you do this infinitely many times, then what you're end up getting is this line. And that is what a graph is. So this is the graph of x plus y equals 10. So by drawing that line with those arrows, we imply that that same trend happens forever in those directions. And any point that is on this line solves this equation, right? So if you are a point on the line, you are a solution to this equation. Check out a different point. What if I select, I don't know, let's select this point right here. Okay, that is not on the line. That is the point 1, 2, 3, and 1, 2. So that would be the point 3, 2. And if you check that, 3 plus 2 is not equal to 10, and that's exactly why this thing is not on the line. Right, so if you're on the line, you solve the equation, and if you're not, or you don't. So hopefully that helps. When you're graphing, you're making a picture of solutions. So maybe I'll just make a statement over here. A graph is a picture of all the solutions to an equation. So let's go down here. Determine whether each ordered pair is a solution of this equation, right? So if you're a solution, then when you get plugged in, you provide a true statement, right? 6 and 4 is on here because 6 plus 4 equals 10. So that would mean that the point 6, 4 is also a solution. That looks like this one actually right there. So what we can do is plug this point in. If it's true, then this is a solution. Okay, so this is my x. It's always in alphabetical order, so x, y, z. So just keep that in mind. So I'm going to plug 3 in for x. So 3 minus 3, and now I'm plugging in a -2 for y, so I'm going to use parentheses just to make sure that multiplication happens well. And then I'm kind of saying, okay, is this equal to 9? If this is true, then this is a point on the equation of this line, which would mean it's also a solution to the equation. So -3 times -2 is +6. 3 plus 6 is 9. So yes. So maybe I would just say yes here as a conclusion. This other one, let's try it. So this is my x and y. So -2 minus 3 times 3, are you equal to 9? Right, we're checking this one to see if it's a solution. So -2 minus 9, is that equal to 9? And that's no. I'll just write no. All right. So I'm skipping down to page 18, example 5. Graph the equation. So remember to graph, which we just did on the previous page, we were looking for solutions to the equation. And something we did was we would pick one, like if I picked x equals 3, and I'm talking about x plus y equals 10 again, but if I pick x equals 3, then it has to be that y would be 7. So what you can do is use what I call, and what some people call the point plotting method. So basically you can pick a couple x's. So what if I pick like x equals 0 and x equals 1? So what I then can do is plug those values in. So I'm going to plug in 0. So do that. I'll go ahead and get the calculator. Feel free to use calculators throughout the semester. So 3 times 0 minus 2, hopefully you can see that, is -2. So I'll write that here. That must mean that there's a point here. So again, here's my x. This is typical to call this x and this y. So in this case, I'm plotting this point. That point says don't go anywhere in x, but go down 2 in the direction of y. So do a similar thing for x equals 1. What you can do on these calculators is I'm just going to press left and edit. So you don't need to completely delete. And now I have a 1. So the 0.11 is also on here. Okay. Should have had a ruler or something with me, but I'll go ahead and use this pen. So all I did was 2 points, right? These are going to be straight lines for now. As soon as you have 2 points on the straight line, you have the entire line. So that's the graph there. So you need the arrows, just to be clear. So intercepts, there's specific parts of the graph that we get into and we want to start to talk about. Also slope, we're going to talk about slope, which is like how quickly things are changing, like the angle of the line. But there's different features that we care about. One of them is slope, and we'll talk about how to calculate slope. Maybe people have seen, like if you have 2 points, let's call this one x1, y1. Let's call this one x2, y2. Then the slope between those 2 points would be y2 minus y1 over x2 minus x1. So that's like how quickly things are changing. Rise over run is another name for this. You may have seen that before. Also a feature of, and that, by the way, would be like this. So this would be the rise, this would be the run. And this value would be the slope. There's also interesting things that we learn from what are called the intercepts. So this one, since it's on the x-axis, would be called an x-intercept. And this one up here, since it's on the y-axis, would be called a y-intercept. And this is a story about a car. So this car originally was purchased for $1,800, okay, a long time ago. It then began to depreciate, meaning lose value over time by $300 per year. So this equation actually describes its value over time. So here's the beginning amount. So at time equals 0, you have an $1,800 value car. And then every year that ticks by, you subtract 300 from that 1,800. So this line is actually a description of all the solutions to that equation, right? So we have the algebra, we have this graphical representation of that algebra. What do those intercepts mean? So this vertical intercept, the y-intercept in this case, that would be the initial amount of the value. So the sale price, right? And then what would be the interpretation of the x-intercept? So this is a number of years, right? And keep in mind that the vertical is the kind of value of the car. So after 6 years, this car is estimated at $0 of value. So this would be the time to reach no value, quote unquote. All right? So intercepts and slope, they're important features of lines. This one asks to find the intercepts. What is going on here? This point is 6, 0, right? And this point over here would be 0, 1,800. Let me refocus this thing. So basically what this is suggesting is that to find intercepts, we often plug in 0, and not only often, but always. So whenever you're looking for a y-intercept, you let x equal 0, and you solve for y. For x-intercepts, you let y equal 0, and you solve for x. All right, so for the y-intercept here, I'll let x equal 0, so I'll have 4 times 0 minus 3 times y equals 12, right? So So that'll be negative 3y equals 12. The multiplication property of equality says I can divide by this negative 3, and we get y equals negative 4. So the y-intercept would be this point 0, right? Because I plugged in a 0 for x. So that's why I'm putting a 0 there for x. And then we calculated that it's a y equals negative 4. So that would be the y-intercept. I'll just make that clear. For the x-intercept, it's kind of equal and opposite. So x-intercept. So I now have 4x minus 3 times 0. I'm plugging in a 0 for the y this time. Right? So we'll have 4x equals 12. I've run out of room, but hopefully you can see that x equals 3. So now this point would be 3, 0, right? The intercepts always have one of their components being 0. All right, let's see what's next. So graph using intercepts, right? So the point plotting method says you can pick points. But what if we specifically pick the intercepts? So I'll pick a 0 over here, I'll pick a 0 over there, right? There's nothing keeping us from that. So when x equals 0, this whole term just vanishes, right? And I have 3y equals 6. Solve 3y equals 6, divide by 3. So y equals 2. So that's the y-intercept, right? Because I let x equal 0. If I do something different and let the y equal 0, then this whole term vanishes, and I just have 2x equals 6, divide by 2, and I get x equals 3. So these are 2 points that I can now plot, right? So again, typical x and y, and then 0 and x and up 2. So that's this y-intercept. Now I go 3 to the right and 0 up. Okay? The graph is the line, right, that connects these two. So it's not enough just to graph the 2 points or however many points you find. We need that whole line with the arrows because remember, the graph is the complete list of solutions to the equation, right? These are just 2 specific ones, but the graph implies infinitely many. Okay. I'm going to skip actually to example 5 here. This is on page 22. So it says, Deb and Christine are walking in the 60-mile breast cancer 3-day walk and want to keep track of the number of miles they still have to walk. They will use this equation. It says D equals negative 3 times H plus 60, where D, this is really always the important part, is what do these variables represent? So where D is the distance in miles they still have to walk after H hours of walking. So actually D is not how far they have walked. D is actually how far they still have yet to walk. H is the number of hours, right? So those little details matter big time. So please do read these kind of statements carefully where they're defining these variables. It all comes down to the definitions ultimately, right? If D stood for dolphins and H stood for hours, then we would have just a totally different understanding of what's going on here. We'd be asking, why are we talking about dolphins and Deb and Christine? But everything does seem to be making sense. They're walking. D is measuring the miles that they still have yet to walk. Find and interpret the D-intercept. So that might sound weird. So usually it's Y over here. So D is kind of like our Y-intercept, just to make a connection. So for the D-intercept, we need to let H equal 0. and solve for D. Right, I'm using kind of quotes here. We're not using x's and y's. So I'll plug h equals 0 in, so D equals -3 times 0 plus 60. 0 times anything is 0. So this is just D equals 60. So we have 0, 60 as our D-intercept, but also it says find, so that's what we just did there, but it also says and interpret. Okay, so that interpretation is important also. So not just finding the point, but what the heck does that point mean? So we plugged in 0 for h. What does that mean physically for this pair, this walking pair here? So if we have a 0 for h, that means they haven't started walking yet, right? So they have done 0 hours of walking. And then what would the 60 then mean off of that? Well, the D is representing how far they have yet to walk. So that would mean that after walking 0 hours, right, after not walking, they still have the 60-mile walk to walk. So that's what it means. So I'll say after walking 0 hours, they have 60 miles left. Right, that's what it means. Sorry. Find and interpret the h, that should say intercept with an I. So for the h-intercept, that's kind of like our x-intercept, usually, right? Because usually it's like a y equals something involving x. Here we have d equals something involving h. So h is kind of playing the role of x. So this means I'll let, maybe I'll use blue again. I'll let d equal 0 and solve for h, right? It's kind of the equal and opposite procedure. So going ahead and doing that, 0 equals -3h plus 60. All right, I've plugged in 0 this time for D. Addition property says I can subtract. So I'll subtract 60, sorry, that's a 60. So I get -60 equals -3h. Multiplication property says I can divide. -60 divided by -3, I'm getting a 20 equals h. So I'm seeing an h-intercept of 20, 0. I was gonna actually box this. So here's my h-intercept, and then again, interpret. We need to find and interpret, right? So this is the find part. So this would mean that they've walked for 20 hours, right? Now we have 20 in the h component, and then d is 0 at that moment. So what is our interpretation of that? Well, yeah, that would mean since d is how far they have yet to walk, they still have 0 miles to walk, so they're done with the race after 20 hours, in other words. So I'll just put it that way. They complete the walk in 20 hours. All right. So I believe we're going on to 3.3. So what if you have points and you want to find the equation of that line? So use the graph to find the equation of the line. You're going to maybe see mention of different styles of equations of line. There is the slope-intercept form, and that looks like y equals mx plus b. So where you have a slope of m and a y-intercept of b. There's also point slope. It's not as widely used, I guess, throughout this course, but it's there. Point slope. So that's if you have a point and a slope. So if you have a point x1, y1, and a slope m, then you can write the equation as y minus y1 equals m times x minus x1. So if you're given a point and a slope, you can just write down the equation, and then you can always convert. So you can always convert this to that, and you often want to. So, and that's kind of why this one is almost obsolete, because we often do want this slope-intercept form, and we can always convert it. So we tend to always convert it. So I've run out of room on this one. I'm going to go down and do part 2. So it says, by the way, use the graph to find the equation of each line. All right. So looking at this graph, I see for sure a point here at -6, -8, and for sure a point here at 2, -2. With those 2 points, I can find all the information. So to find an equation of a line, you either need 2 points on the line or you need a slope and a point. So what I'll do first is actually use the slope formula. So a little while ago I did write it down. Okay, what I'll do is I'll call this my first point, and I'll call this my second point. So this is x1, y1, and this is x2, y2. So that would mean that the slope between those 2 points, I'll go ahead and plug in accordingly. So -2 minus -8, right? So y2 minus y1 over 2 minus -6. So x2 minus x1. And then we need to simplify. Right, so -2, a negative times a negative here. So this will simplify to -2 plus 8, actually, in the numerator. And then a negative again times a negative. This turns into 2 plus 6. So I have 6 over 8. And that can reduce, right? I can cancel common factors. So 2 times 3 up top, 2 times 4 below. So that slope would be 3/4. What I can then do is simply find the y-intercept. Right, so what I can do is go ahead and maybe plug into this equation. So right now I know that y equals 3/4 times x plus some y-intercept, right? We still need to figure out it. It looks like the y-intercept is right around here, by the way. Right, so it's not a complete guess. It should be somewhere between, it looks like -3 and -4. But how do we find it? What we need to do is use one of our points. I'm just going to select this one. I'm going to plug in x and y. So -2 is coming in for y equals 3/4 times 2. Which is replacing x, and then I can solve for the b. Right, so that'll give me something to solve for b with. So what I'm going to do, just to help myself out, is do this a little arithmetic with the calculator. So this button here, that fraction button, use it. So 3/4 times 2. So I have 3/2 on the right. So -2 equals 3/2 plus b. What I want to do is subtract 3/2 now, right? I want to isolate b so we can figure out what the y-intercept is. So here, something you can do is go -2 minus answer, right? Because the previous screen, the screen just before this, had 3/2 on it. So if I do -2 minus answer, it's reading answer as 3/2, right? -3/2. So -7/2 equals B. If you ever want to go from a fraction to a decimal, you press this button here, this S to D button. So press that. So that is -3.5. So the equation of that line in the end is y equals 3/4 x, right? The slope that we calculated earlier from over here. And then we just found that it was -7/2, right? Same as -3.5. This is the equation of that line. All right, so going on to page 24. So this says, using point slope form, find the equation of the line passing through the points -2, 5 and 2, 3. Put the final answer in slope intercept form. Okay, so it says using point slope form. What if I just ignore it? I'm just going to ignore it. So let's find the slope. So x1, x2, right? This would be y1, y2. So y2 is 3 minus 5 up top. And then x2 would be 2 minus x1, which is -2. So this is the slope calculation. So I get -2 over 4. In other words, -1/2 for the slope. Right, so right now I know y equals -1/2 x plus some b that we still need to solve for. How do we solve for the b? We pick either of the points. It doesn't matter which one you pick. You plug in that point for x and y, and then you solve for b. So I'm just going to choose this one for no good reason. So I'll plug in x equals 2, y equals 3. So we have 3 equals -1/2 times 2 plus b. -1/2 times 2 is -1. And then add 1. So 4 equals b. So I can write y equals -1/2 x plus 4. All right. Yeah, I'm gonna do one more. So on page 25, this one uses a new term, so I wanted to include this in the video. So it says perpendicular. Find an equation of the line perpendicular to this given line passing through this point. So perpendicular basically means a right angle. So like these two lines are pretty close to perpendicular. These two lines are pretty close to perpendicular. These two lines are not. Right, so perpendicular is similar to these. If you can imagine the perfect case of these, what you need to do is if you have a slope m, so if you have a given slope m, then your perpendicular slope is actually -1 over m, strangely. So we have a given slope of 3/7. So what we need to do is find this. So we'll do -1 over 3/7. Right, so I'm basically plugging in m here. So I'm taking -1 over 3/7. Use this calculator a bunch this semester. I encourage you to do so. Hopefully you can see this. So fraction, we have a fraction, but then in the denominator of that fraction, we have yet another fraction. So I'm going to scroll up, go -1, scroll down, and then type in my 3/7 and then hit equals. So it's -7/3, right? It flips everything. So this is our slope, our perpendicular slope. Sometimes we use that notation. This little subscript saying slope perpendicular. All right, so right now I know y equals -7/3 x plus b, where b is again that, as of right now, unknown y-intercept. Okay, so what I'll do is I'll use the point. They only gave us one point. So I'll plug in a x equals 6 and a y equals -1. So -1 equals -7/3 times 6 plus b, right? And we're solving for b. 3 goes into 6 twice, right? Then 2 times -7 is -14. So -1 equals -14 plus b. And then I can add 14 to both sides. So these cancel. So 14 plus -1 is 13. So I have 13 equals b. So the line that both is perpendicular to this line, but also contains this point, is y equals -7/3 x plus 13. All right, talk to you next time. Have a good one.